Very good morning to all. In today's lecture, we are going to discuss about a machine tool gearbox. The learning outcome from today's lecture, right? Understanding about GP, which is gear proportion, right? Step ratio, preferred numbers, and structural formula, rules of optimum gearbox, ray diagram. So, you are going to understand about GP means geometric progression of gears, step ratio, preferred numbers, structural formula, rules of optimum gearbox, as well as construction of ray diagram. So, the purpose of the machine tool gearbox is to do various manufacturing things. When you say various manufacturing operation, is talking about making turning, milling, grinding, etc. So, obviously all your lathe, milling machine, grinding machine or turning machine will need a gearbox. The purpose of the gearbox is to give a precision depth of cut. When you want to have a precision depth of cut, you need to have what I want to say, that feed and speed. Okay, the feed and speed are very crucial for the machine tool gear operation aspect. That is the reason these machine equipments generally use a machine tool gearbox. So, the purpose of the gearbox again will have following things. It should provide a designed series of spindle speeds. It should transmit a required amount of power to the spindle. It should provide smooth silent operation of the transmission, and it should have a simple construction, and the mechanism of speed of gearbox is easily accessible. That means the operation as well as maintenance of the gearbox should be easy for any other things. So, these are the main 5 important points for the requirement of gearbox in machine tool application. So, when you say this is the typical machine tool gearbox, you could see that there are so many what I want to say, that gears are there. You can see that the lot of gears, you can see that, which clearly shows this is unlike automobile gearbox. This gearbox would need a lot of speeds. When you talk about speeds, you can have a 12 speed, and you can have a 18 speed gearbox, right? GB is a gearbox, 24 speed also. More the precision, you can have a more speed, 28, so on. So, like that the gearbox can operate in different speeds aspects. So, the important thing is to have to select the proper gears. The moment you say proper gears, the space is very limited. So, we want to have as minimum as possible, right. So, when you want to have as minimum possible gears, obviously you have to go for the geometric progression. So, in the geometric progression, what happened? The gear type. So, the speed loss is minimum, the number of gears to be employed is minimum, it provides a more even range of spindle speed at each step, and the layout is very compact and simple. Normally, in gears we will have a arithmetic progression, AP, arithmetic progression, that is one is there, arithmetic progression. Then you have a GP, geometric progression, and one more is logarithmic progression. The logarithmic progression extensively used in automobile gearbox. We will discuss why, okay, what is the reason logarithmic aspect. So, these are 3 different progressions. Within that, usually preferred is geometric progression and logarithmic progressions. And very important thing is a step ratio. When you talk about step ratio, the different speed, the ratio between the two adjacent gears will give a step ratio. So that is normally assigned as a psi, that is a symbol. You can see that the ratio between two adjacent speed is known as a step ratio or progression ratio. Normally you can say this is the equation where you talk about n2 by n1, okay, two adjacent gears will have a step ratio 5, and if you have more gears you can have n3 by n2 and n4 by n3 and so on. Finally you can see this, you can have n max by n minimum. So when you have n max n minimum, the step you will have a logarithmic aspect. You can see here where psi is the step ratio, x is the characteristic formula. Okay, x is the characteristic formula. You can see this where n1, n2, n3, n4 are the spindle speed in geometric progression, and n is the number of steps of the steps or number of speed, where x is the characteristic stage or group. So the x will indicate how many stages we will have in the gearbox. This is in fact number of stages. Number of stages different from a number of speeds, whereas n is the number of speeds, we will already given number of speeds. Okay. Right. So rearranging this this equation, you will end up in this way. Yeah, simple thing. And and again in practice it's difficult to get a fraction of gear, right? Can you get a 34.5 teeth gear? No, you have to have a whole number. So to accommodate, normally the permissible deviation given 10%, which is nothing but plus or minus 10 into 5 minus 1. This range is allowed for the gearbox aspect. And now we will go to the important aspect, is a preferred number. The preferred number is talking about the what type of series you are going to have. Okay, this preferred number, what type of series? A preferred number are number of rounded off values derived from a geometric progression series. The series, there are 5 series, R10, R5, R10, R20, R40 and R80. Okay. Normally gears are manufactured, so they are available in the shelf over the counter. So easy to, the reason is easy to manufacturing and the cost should be cheaper. You don't want to have a random size, so you need to have a standard preferred number. That is the reason the preferred numbers are given, and you can see this is the R5, again the step ratio, right, 1.58, R10 1.26, R20 1.12, R40 1.06 and R80 is 1.03. Numbers increasing, the basic series increasing, the step ratio increases. The step ratio decreases, you will have more speeds. We will see in a minute. You will have more speeds availability. Sometime apart from standard step ratio, you will have a non-standard also. Okay, so I will tell you what is that non-standard aspect. Suppose if you want to have a different series, I want to have a, like suppose 520 by 3, right? So they will give you a different step ratio. 20 by 3 root should give 1.41. This is a non-standard series. So I will discuss in detail later stage. Now the basic series of preferred number, as I explained, R5, R10, R20. Now you can see that these are the speeds for corresponding given series. R5, you can see that R5 has the ratio 1.6 and you have a number of available numbers are 6. And one more thing, if you take it the ratio between two adjacent, that should maintain the step ratio. So 1.6 divided by 100 will be, sorry, divided by 1, 1.6. Similarly, If you take it 2.5 divided by 1.6, what is the number you will get? That should be 1.6. Sorry, this, yeah, that should be rounded off to 1.6. If you take even randomly any other number, maybe I will take R10, right, R series 10, the difference between 5, I will choose this one, 5 by 4, that should expect 1.25. Okay. So, always between two speed, adjacent speed, the ratio has to be maintained. And if you observe this table, I have taken from the PhD data handbook, it clearly indicates as step ratio decreases, your preferred number of speeds are more. If you look at 1.6 as a 6 number, whereas R10 is increases, R20 even more speeds. The moment you decrease your step ratio to 1.06, look at this series, you start from 1, the step ratio to 10. This availability of preferred numbers are more as decreasing the step ratio. Okay. So, in fact, randomly we will check whether the step ratio is matching or not. Probably can we take this speed, these two numbers. Okay. If I choose 5.3 by 5, that should give me 1.06. Is right? Yeah, probably I will do it here. 5.3, 5, the step ratio should give 1.06. So, such a way that the numbers are staggered in the all 5 series. Right. Now, recommended values of 5 in machine tools. So, these are the things you can see that. So, for a heavy duty machine tool and automates operation, you need to have a higher 1.12 the 5 value. When you move on to the large to medium size general purpose machine tool and automates, then you can go for a 1.25, and if you have medium size general purpose machine tools 1.41, and you have medium size medium to small size general purpose machine tool, you can go to 1.5. It clearly indicates the more the precision, lower the step ratio. Okay. Whereas the general purpose is its accuracy is not very important, right? The precision is not important. In that case, the step ratio can be higher. That's the information you will get it from this table. Now, we will move on to the important thing is structural formula, which is the signature or labeling the gearbox aspect. So, normally n is the number of speeds, that already you have known that. Okay. So, number of speeds is n, will give you this kind of P1 into x1, P2 into x3 and P3 x3 and P4 x4. Okay, like this is given. So, this nothing but this indicate about the stages. This is stage 1, this is stage 2 and this is the stage 3, and maximum we can go for stage 4. This is indicate about the structure of the gearbox, that is why it is given structural formula. Okay. So, we may wonder what are the P1 x1 and P2 x2, something like that, right. So, if you look at that, first stage, second stage, third stage and fourth stage, and where x1 equal to 1 and x2 equal to P1, x3 equal to P1 P2, x4 equal to P1 P2 P3. So, I will come back to you what does that mean. So, what is you see the P1 x1, right, the P1 x1 this is given. So, normally within the bracket it talk about input speed, within the bracket indicate about the input speed. Okay. Then anything before that it comes as a output speed, right. For the gearbox, where do you get the speed, input speed? It should be from motor, right. The input speed for gearbox should be from motor. So, when you talk about motor, so that will be the only one speed, right? Whatever the setup, that will be one speed. So, obviously my x1 will be 1, my x1 will be 1, okay. So, this x1 will give a one input speed, I will get P1 as a output speed in stage 1, okay. Now, move on to the stage 2. In stage 2, right, stage 2, so always say stage 2. So, what is the input speed, what is the output speed? The input speed is your x2, right. Input speed is a x2, right, is a x2, right. Then output speed will be supposed to be P2, okay. So, where is the input speed coming from for x2? It should come from stage 1, right, it should come from stage 1. So, where is the stage 1 output speed, what is the stage 1 output speed? P1. The P1 would be the output stage of first stage, P1 would be input speed of second stage. Suppose, so that means my x2 would be P1. Is it clear now? Right, it is clear. Now, we will go to the stage 3. So, what is the input speed? I will put IP, so easier. Input speed, what is the input speed? X3. My output speed? P3, okay. P3, right. So, but I know that my x3 will be the sure, that is correctly, that is the input speed, fine, and output speed is the P3. So, whatever the output speed of stage 2 should be input speed of stage 3. So, what is the x2? Sorry, what is x3? It will be P1 into P2, okay. So, that is what you see, that this is a P1 into P2. Similarly, stage 4, in stage 4 what do you expect? The input speed x4, right, then output speed P4. So, x4 nothing but P1, P2, P3, that is what you see, that, yeah. P3. So, now can you see that how importance having a structural formula? Structural formula will not only indicate about the number of stages and also tells about the input speed and output speed of each stage, okay. So, the P1, P2, 3 stage numbers in the gearbox, which I already have explained that. So, now very interestingly we will go for the structural formula, okay. So, before the structural formula, assuming that I have a speeds, I have a 6 speed, okay, 6 speed gearbox, how do I arrange it? 6 speed gearbox, how do I arrange? I can arrange 3, 2, right, I can arrange 3, 2, or else I can arrange 2, 3. I am just giving you how to arrange the structural formula. Normally, it is better to start with the more reduction at the beginning itself, so that the torque requirement can be overcome, okay. So, let us see. So, when you have a 3, so 1 input speed, that should give me, right, 3, 1, then the 3 is the input output speed of stage 1 should go to stage 2 as a input speed. So, if you multiply 2 into 3, I should get 6 speeds, right. Similarly, one input always 1, right. So, this is my input speed and 2 is my output speed. One input will give you 2 output speed, right. Each output will give me a first stage will give me 3 output speed of stage 2. Okay. So, this will goes here, when it goes here, okay, this is input for a stage 2 and this is your output. So, each there are 2 in fact, please remember there are 2, one will give you 3 outputs, second another give 3 outputs, totally you would expect 6 speeds. Okay. Let me give you one more information. How about 12 speeds? We will have 12 speeds. 12 you can have various combination 3, 2, 2. Okay, that's let us see. So, obviously I will have a input 1, right, input 1. So, this is output for first stage, then if it goes here that will be input to the stage 2, right, then 3 into 2 6, right, this right 6 will give me as an input, right. So, 2 into 6 I would expect 12 speeds. So, you clearly understand that the structure formula how is useful. It not only gives about the arrangement and also tells about each stage input and the corresponding output speeds. Yep. Okay. One more thing is I'll give you what does it mean. 6 means you have 6 speeds. That's one information, and also the 6 indicate 6 steps ratio. That's a formula, right? That's what we derived, right? That's a formula thing. Let me give you one more information. How about 2, 3 and 2? How do you arrange it? How do we arrange? So, 2, so 1 input speed, 2 output. So, that should give me 2 output speed. Will goes to here to the second stage. 2 into 3, 6, right. Then the 6 will be here, then 12 speeds. Then another arrangement you can have a 2, 2 and 3. 1 here, then 2, then this should be 4, isn't it? 3 into 4, 12 speeds. Okay, very interesting, very interesting. Okay, how about 18 speeds? How can we arrange 18 speeds? Yes? How will we do the 18 speeds? 3, 3, 2. You can do that, yeah. So, 3, 1 input speed, then 3 into 3, right, and this should be 9. So, you will have a 18 speeds. Again you can change the various combinations same way. You can have a like 3, 2, 3, then 2, 3, 3. So, this is the way you can do that, and this should be 6, 18 speed. Sorry, it will be 2 and it again 6, right, 18 speed. Excellent. How about I have gearbox with the speed of 14, how do I do that? Suppose gearbox has a 14 speed instead of nice 6, 12 or 15 or 18, it has a 14 speeds, which is not the standard one. In the case, how will you do that? Can you do 2 into 7? Do you think such a large reduction would be feasible? Right. So, then how can we accommodate? How can we accommodate for gearbox 14 speed? 14 speeds gearbox. How do I do that? So, in fact, already we know the 18 speed structure is given. With that, we can construct. With that we can construct. So, assuming that this is 3 and 3, I will come back to the third stage. So, 3 first stage, right, 1 input, 3 output you will getting, yeah. So then the 1 into 3, there will be 3 that go as a input speed to the stage 2. So then 3 output speed, each one input speed will give you 3 output, that will be 9 speeds, right, 9 speed you will get it. The 9 should go to as a inputs to third stage, right, but I need only 14 speed. So what I can do, 9, because it's a structural formula 18 speeds, so if I subtract 4, I would expect 14 speed. 9 minus 4 should give me, right, it should give me 5. So in this way I can arrange. You may ask question, what happened the remaining 4? Because the gearbox itself is 18 speed, so we can't eliminate. So instead of elimination, we will give a 4 speed as the ideal speeds, right. When you have ideal speed, what happened to gear ratio? Will be remain same. That is how we do the arrangement. Okay, I will give you one more combination. So we will have a 4 and 2, okay. 1 is the input, then you will have a 4, from 4 you will have 8, okay. Tell me what is that one we can have from here? 4, 2, 8, 8 into 2, right. So what can we do? 2, right. So instead of 8 minus 2, that should give me 6. So in this arrangement, so we will have a 2 idler speed. So this number indicate about idler gears. The rounded numbers 4 and 2 indicate idler gears. This is the way you can arrange the gearbox, okay, for if you are having odd speed. How about maybe 15 speed? How will you do this 15 speed? Yeah, speed for gearbox. Just think about it. Yeah, 15 speed. What is the standard structural formula we would expect? Right. So I can show the structural formula table now. Again, it's taken from PSG data handbook. You can see here you have different speeds are given. You can see 6 speeds is given. So 3, 2, 2, 3. So preferred always start from higher ratio to the lower thing. So that's what I said earlier. You can see the 8 speeds, 2 to 4 and 4 to. So the preferred one, anything is the top, it's a preferred one, then least preferred at the bottom. And look about 9 speed, 3 into 3, 12 speed 3, 2, 3, 2, 3, 2 and 2, 2, 3, and 14 speed as I said 3, 3, 2. Look at 2, 5, right? 2 within the bracket 5 and 2 within the bracket 6, right. You can see 15, 3, 3, 2, very easier. Then 16 speeds also. Again 16 speed, again you will use the structural formula 4, 2, 8, 8 into 2, 16. Straight away you can see that 2, 4, 2, same way 2, 2, 4 and 18 speed 3, 3, 2, 3, 2, 3 and 2, 3, 3. This is the way you can arrange for the gearbox stages aspect, right. Now we will move on to the basic rule for optimum gearbox, right. As I said, even though it's a machine tool gearbox, the gearbox should be compact, then will have less number of gears. That is the optimum thing, okay. Weight is fine, but at least the size should be as compact as possible. So number of gears on the last shaft should be minimum. That's the reason at the beginning itself we will have a maximum reduction, right, at the beginning itself 3 is given, okay. Then the number of gears on the shaft should not be more than 3. So, that is the reason normally we will have a maximum 3 or 4 stages. We do not go beyond that. Then it will be a lot of dynamic and other design problem will exist. It is preferred to have in the arrangement which is very critical, the speed arrangement. The speed arrangement in this order. Okay. Your N max and input, always this is the one we are going to play around. Input speed should be greater, should be lesser than your speed, and maximum speed at the same time should be greater than minimum speed. I will tell you why it is, and also this should be followed in all stages except the first stage. Except the first stage. The transmission ratio between the between the spindle and the shaft preceding it should be the maximum possible, that is speed reduction should be maximum possible. Maybe I will give you what is the meant. Okay. You can see these are the two things you have to follow. When you want to have a gear up, you can go as maximum possible 2 ratio, I max the gear ratio, N max divided by N input less than or equal to 2, and I minimum, which I indicate about the gear ratio, again the ratio between the N minimum and N input speed should greater than or equal to 1/4. So, whatever the gear arrangement must be followed within these two limits. Within these two limits, we will discuss about the basic rules for optimum gearbox again continuing. So, for stable operation, the speed ratio at any stage should not be greater than 8. You have seen 2 and 1/4, right, 4, right. One is to gear ratio 2, another is gear ratio 4. Gear reduction is 4. So, obviously, you cannot go beyond 8. That is clearly indicates you have to choose within the I max and I minimum. The minimum number of teeth on the smallest gear in driver should be greater than or equal to 17. This is to prevent or to avoid interference, okay. And the minimum difference between the two between the number of teeth between the two adjacent gears at least must be 4, okay. And whatever we discussed is we are talking about sliding mesh gearbox. We are talking about, please understand this all we are doing the sliding mesh gearbox aspect. This is applicable only sliding mesh in machine tool gearbox. The sum of the teeth meeting gears in the given stage must be the same for a module in the sliding gear test, which indicate about the center design is fixed. The center design is fixed, and also whenever the gear are wanted to mesh, they should have the same module. What happens if you have different modules meshing each other? It won't be possible, right. You have to make sure the mating gears must be the same module, right, okay, such a way that the transmission can be taken place. Gearbox should be of minimum possible size. Both radial and axial dimension should be as small as possible, right. Both radial and axial dimension should be as small as possible. Now, we will talk about the ray diagram. So, ray diagram very interesting one, okay. Earlier we talked about the structural formula. The structural formula gives information about the stages and input and output speed of each stage, whereas ray diagram will give you the connection between the stage 1 and stage 2, stage 3 and stage 4. In fact, you look at here, it is a graphical representation of the drive arrangement or structural formula, that is the critical. The number of stages and number of speeds also will be specified or will be able to find out using the ray diagram. The order of kinematic arrangement of the stages. So, the ray diagram would be helpful to construct the kinematic diagram. When you say kinematic diagram, the arrangement of the gears in the each shaft for the each stage, and the specific values of all the transmission ratio in the drive can be observed, and the total number of speeds available at each spindle. That's you can be observed or inferred from ray diagram, or sometimes it's called speed diagram. You can see this ray diagram. So, actually this is a given. Can you see that this is the ray diagram? Okay. So, the vertical axis indicate about the shaft. This is indicate about the shaft. Actually, this is the input shaft, and this is your output shaft. Intermediate, you have again intermediate shafts. These are again shaft at the vertical lines. Okay, and this is actually stage 1. This is stage 2, and this is stage 3. You can see this. The formula rewrite again 2 1 3 2 and 2 comma 6. So, this is a 3, right, and this is 2, and this is the 1. And interestingly, if you look at how it's able to do that, okay. And one more thing is, it's in the log scale, okay, it's a log scale. This is the, these are the speed indicated, this is speed, these are the speed. All of them will have a, can you tell me, this is one speed and another speed, what happened between these two ratio? What does it represent? The step ratio. Each one will have a step ratio, okay. They have to maintain, step ratio, okay. That's the arrangement is given. Yeah. Now, I will explain that. So, you have a stage 3, 2 6, that means 2, how many input, how many output, right. 6 will be 6 input, right. You will have 6 input, maybe I will write other way around. Input 6, output will be 2, right. I am talking about third stage, okay. See, look, I am just taking, this is the one input. Look at this, I need to have a 6 inputs. How many inputs are there here? 1, 2, 3, 4, 5 and 6, right. You have 6 inputs. Each input should give me how many outputs? 2 outputs, okay, 2 outputs. So, I have 2 outputs, but how do I place them? 2 outputs I have to place with the apart of 6 step ratio. Understand, right? You have 6 inputs, that is clear, right. At the same time, the 6 will indicate the distance or the step ratio, number of times step ratio between the 2 output speed. In fact, if you look at, this is my lowest speed, right, and this is one output speed, and this is my second output speed, okay. Find out how many step ratio there, 1, 2, 3, 4, 5 and 6. Can you see that how structural formula very useful now, right. It not only indicate about the number of input speed, and also will indicate about the difference of two outputs, okay. So, you can see that. So, similarly, if you look at, so you can have, this is nicely done, right, you can see here. Similarly, this one, this another input, you can say that out, right, that is the input will again have a 6 output. If I choose from here to here, look at 1, 2, 3, 4, 5, 6, that is maintains, okay. Now, I will move on to the, I just indicating about one aspect, one branch aspect. This is second stage. In second stage, you have the structural formula 3 2. So, this is would be what, then what is the inputs, how many input speed? 2, right, 2 input speed. Then how many output speed I should get it? 3 I would get it, right, 3, right. So, look at that. So, how many I have here? 2, right, 2 input I have, right. Each input should give me 3 output. Look at this, 1, 2 and 3. Now, can you see that how we are linking the structural formula, right. Now, finally, this first stage 2 comma 1. Obviously, one input speed from the motor, that should give me 2 output speed, 1 and 2. So, this is the way the ray diagram constructed. Okay, this is the way ray diagram constructed. I think I will stop now. We will discuss again in tomorrow lectures the other aspects of ray diagram, and also we will do the problem. Thank you.